trèSci Weekly, episode 34. Today is Monday, October 2nd, 2017. I'm one of your hosts, Jonathan Ullman, alongside a man who found his way across the Pacific Ocean after 6 years of floating on a barge from Japan. Made his way to the West Coast, where he got picked up by Kyle in an RV, hitchhiked his way with Kyle across the country to the East Coast, where he met John and started a science podcast. Ladies and gentlemen, Tom Kea.
Thank you for the great introduction.
You're welcome. You're welcome. I'm toying with the idea, Tom, about giving you an origin story for each episode now.
Because the good one.
The little tagline. I've had good ones. I've had bad ones. Thinking about getting a little more in depth.
Cool.
So, how are you?
Good. So before we get started and do our thing, a few stories we've been following that we're not going to talk about. As you mentioned, traveling across the Pacific Ocean for quite a few years, there was a tsunami in Japan. That was in 2011, right? So all that debris finally made its way over to the west coast of the U.S. On like barges and boats, all the debris that floated over. And something about 300 species have been identified from Japan here on the United States.
Yeah, so a little biodiversity happening over here. Some ecosystems, I'm sure, gonna get disturbed, maybe, or
who knows if it'll be invasive or whatnot.
Yeah,
we'll have to see.
Pretty interesting stuff.
And then they started announcing Nobel Prize winners today, right?
That's true. I haven't looked too far into it just yet.
I think they only officially announced the one.
Yeah,
right. The
physiology and medical one, right?
And that was the circadian rhythm, where they were doing research to see how during the day, basically the biochemical system in your body works due to the sunlight that you get, and like how that affects your rhythm of needing to sleep and how you function, basically. Yeah. So they did research into that.
Yeah, might take a deep dive into that for next week. Yeah. So stay tuned. If you're joining us for the first time, welcome to trèSci Weekly. Welcome to our weekly podcast video series where Tom and I discuss trending science news topics for about an hour. You can watch this show live on Monday nights at 8:30 p.m. as some of you guys are doing, and we appreciate you if you do that because then you are chatting with us, discussing the stories as they happen, getting that hot take personal feedback. If you can't do that and you watch the show on YouTube after the fact, we appreciate you still.
Of course.
We would ask that no matter when you watch the show on YouTube, that you would consider subscribing to the channel here and thumbing up the video if you like what you see. That always helps grow the stream. We also have some social media places where you can find us. Facebook.com/trèSci Weekly and Twitter.com/trèSci Weekly, where you can like and follow us respectively. And finally, if you would like to donate to the stream, you can always go to Patreon.com/trèSci Weekly and donate any amount of money that you would like.
Yep. Sorry about that.
No problem. And we have a new month ahead of us here, Tom. So I want to give a shout out to all of our patrons that do support us. So I think I'm trying to think of who is on there. So we have Ryan Nash.
Yep.
Juan Gonzalez.
Yep.
Your mom.
Yep. Hey, no mom jokes. Please.
No mom jokes. And of course, Big Papa Bear, Dan Smith.
Yeah.
Is that everybody?
And I believe my grandma.
Your grandma.
I believe.
And Kayla's mom.
That's
right. That's right.
So we're sort of family funded, as
we are
at this point in time.
But we're ad free because of it.
Because of
so that's great.
Our kind friends.
Tom, we've got some really interesting stuff to talk about this week.
Yes, we do.
Some good news, some not so good news, some videos to share with everybody. So I want to start on a high note, and then we'll work our way down, I guess. So first story of the week, the 68th International Astronautical Congress, or the IAC.
Astronautical.
Yes. Took place last week and was held in Adelaide, Australia from September 25th through 29th. On Friday of that week, SpaceX's Elon Musk delivered a presentation titled Making Life Multiplanetary, which revealed the company's plans for future space colonization.
Yeah, it was about 45-minute presentation.
Yep. There were lots of presentations at this, of course.
But just his part, yeah.
Yeah, so I felt like his SpaceX and Elon Musk was kind of the high note of the whole thing here. The keynote focused on design aspects for a rocket currently codenamed BFR, which stands so far for Big Effin' Rocket.
Yes, it does.
Which would combine the designs of SpaceX's Falcon 9, Falcon Heavy, and Dragon spacecrafts into one system. So I want to ask Kyle to bring up our first image of that. A lot of these slides are going to be the slides that we saw during the presentation.
During that presentation.
First image here, as Kyle gets it up for us, awesome, is a little size comparison of BFR versus some of their other rocket models over there at SpaceX.
And the goal is to make BFR be able to do what all three of the previous ones would do together, right?
Right, so...
Sort of just take the place and be able to do what they all do, kind of?
Kind of, right? So you have Falcon 9, which is a rocket that is able to be sent up into low Earth orbit.
For example, like a satellite or something, right?
Right, and then they have their Dragon cargo spacecraft, which delivers supplies and laboratory equipment to the International Space Station, and they basically want to combine the assets of both of these things. That way, all of the research and funding that's gone into developing them doesn't just go to waste. Right?
Yeah, sort of use what they learned, and now that they can re-land the rockets and reuse them, they're sort of like, let's put them all together and see what we can do with it.
Yep, which makes a lot of sense. So BFR is the BFR, right? It's the big one here on the right hand side. It's next to the Falcon Heavy rocket, which SpaceX is beginning production of, I believe, at the end of this year, which stands next to Falcon 9, which they've been kind of mastering their landings.
I forget how many successful in a row, but it's a bunch.
Yeah, it's like over 10.
Yeah, it's
least.
over 10.
Yeah. And then next to that is the Falcon 1, which was the first rocket that they developed over there at SpaceX. And then the little dot that you see all the way at the left, that would be a person for a size comparison there.
Cool. So what he actually mentioned during his presentation, which I just remembered, was that when they first started using the rockets, I think it was, I forget when it was, like 9 years ago or something, he said that it was basically, if this doesn't work, we're kind of just not really going to do SpaceX.
Yeah.
And then it kind of worked out, and then they got to move forward and forward and forward. Now he's like, and now I'm talking about moon bases. And here we are.
Yeah.
Pretty cool.
Definitely a really nice little success story. All right. So, Musk focused on reusability and orbital refueling as essential aspects to keeping the cost per spaceflight launch down with BFR. And we have a couple more slides to bring up for that. So, the first slide here was showing a comparison of rocket capability, and BFR is all the way on the right-hand side, meaning that it's going to be able to deliver the heaviest payload into low Earth orbit out of any rocket that has ever been developed before. The next runner-up is the Saturn V, which was used to basically for the Apollo missions, getting those astronauts to the moon. So that was obviously a huge payload delivery as well. So BFR is going to top that, but reusability is something that SpaceX has been really kind of honing their craft in. And so if we jump to the next slide that was launch cost, you'll see that when you take reusability into account, that BFR actually becomes the cheapest rocket to launch per launch.
Yeah, so it's more basically efficient.
Exactly. So that's pretty exciting.
Yeah, Yeah, he really tries to drive home the point that it's really all about the reusability. That's really what SpaceX is all about. That's the future of the space industry, he believes, basically, is that once you have the system in place and it's reusable, now it's something that we can feasibly do on like a day-to-day type thing.
Yeah.
Make it real.
Yeah. I mean, it makes total sense. And again, the way he puts it is like, well, we launch these rockets and then they're, single use only. They blow up afterwards and they cost
so much
millions
money,
of dollars. Yeah. This is madness. This is crazy. Why do we do this? So, yeah. So this
it turned out that it's kind of hard to, reuse it. But, now that they got it working, it seems like, should have done this the whole time.
Right.
If it was that easy. But
in addition, Musk outlined a series of plans to generate revenue so that development and production of BFR could begin as early as in 6 to 9 months' time. The first method involves using BFR size to advantageously deliver or remove larger satellites or many smaller satellites into low Earth orbit at a time. So we have another image to bring up here. This is all concept art now from here on out. So this would be a concept of BFR, releasing a much larger satellite into low Earth orbit than can currently be done.
Yeah.
So he was quoted as saying, "We can actually send something that is almost 9 meters in diameter to orbit. So for example, if you wanted to do a new Hubble, you could send a mirror that has 10 times the surface area of the current Hubble as a single unit. It doesn't have to unfold or anything," end quote.
And that's just due to the size of the BFR payload.
Exactly. So, yeah, so that's definitely going to be a way for them to make money
and fund this vision. Yeah.
Alongside. Which that I think was really like...
That's the key part of the presentation, right? Like, this is how we're actually going to do it.
Yeah. That, you can dream as big as you want and have ideas forever, but until you figure out a way to, pay for all of them, it's just pie in the sky. So I like that this was, like, a real promise here. Like, this is exactly how we're going to do it. In addition, BFR would also be utilized for servicing the International Space Station, even though it looks absolutely ridiculous in this image to do so. And Kyle can bring that next image up for us.
It's a pretty large...
Right? It's like bigger than the
space station.
Than the whole space station, so it looks crazy.
But he said it's still able to dock, right?
Yeah.
And what we're seeing on the bottom there, that little dorsal fin looking thing, he explained that was for... I believe landing it in some harder environments where you need to angle your drag to determine exactly how you're going to be able to land.
Yeah.
So having that fin on it, they designed it so it can land on a whole bunch of different environments. So if it was going to land on the moon or on Mars, obviously there's different gravity conditions, different ways you'd need to do it. And they found the easiest way was just adding on this little fin allowed them to change enough of their aerodynamics and stuff to allow it to land on different gravitational surfaces.
Right. And different air densities.
And air density, yeah, exactly. Because the atmosphere is different on the moon and Mars as opposed to Earth. Exactly.
On top of that, SpaceX figures that BFR can achieve lunar surface missions without the need for a way to produce propellant on the moon, since a return trip can be made possible with a high elliptical orbit refuel prior to lunar landing. This opens up the possibility for the creation of a permanent lunar base, and we have a concept image of that as well.
Nice.
Very cool.
There's a little picture of a crane. That's how you get the stuff out of BFR.
Yeah, I love how that had to be explained as well too.
He's like, yeah, there's a crane.
Yeah. Not very difficult. Yeah, I really like that this could become a reality pretty soon.
Yeah, so the whole concept is that you launch it from the Earth, and then to get it to the moon, once you're outside of Earth's atmosphere, it doesn't take a lot of fuel to get you to the moon and back because there's less gravity, no atmosphere. So once you get it into that, they call it high elliptical orbit. So once you're out of the Earth, then you're in the orbit, you can refuel and then use a small amount of fuel, go to the moon, and come back without needing propellant on the moon.
Right.
So it seems like an actual realistic way to go to the moon and come back without tons and tons of money, basically, and able to redo it.
Yeah.
That's the whole point. It's like you can have the base now that once you have the rockets, now there's this system in place. It's like as soon as you build the public bus transportation, then this whole system gets set up.
Right. You just got to do it the first time. Basically.
Exactly. But that was the whole trouble, is that how do you feasibly reuse these rockets so we can actually go here multiple times? So this infrastructure needed to be built in order to have a moon base, right?
Right.
It's not possible with currently what we've been doing.
Right. You have to achieve a way to refuel in orbit, right?
Yeah.
Like otherwise, it's not gonna really work. That's why it was crazy for the Apollo missions, is because they had to have enough propellant for the whole. Like they had to move enough propellant off of the Earth so that they could then launch off of the moon. It makes your trip that much heavier, so it costs that much more to do it.
And then once you do it, that's it.
Yeah.
Right? So, pretty cool.
Yeah. Then finally, the granddaddy mission of them all, a trip to Mars. Getting BFR to Mars seems just as possible as getting it to the moon, just requiring more fuel refilling. Getting BFR off of Mars, however, would require a localized propellant production. Since the propellant is simply liquid oxygen and methane, the ingredients are all readily available, as Mars's atmosphere is made up of carbon dioxide, and Mars is confirmed to have H2O water ice. So you have CO2 and you have H2O. You can do a chemical process in order to segregate out the O2 and the CH4 from those. So
to make the propellant you need to
then refuel on the surface of Mars.
And then leave.
Yep.
So now it's no longer a one-way ticket.
Yep.
Which people were saying was the main problem only pretty recently, right?
Yeah. And the other piece of the puzzle here is that you only need the payload to launch from Mars, because Mars has less surface gravity. So you don't need the booster. You don't need that long part of the rocket. You just need kind of the top payload to be able to come back from Mars.
Gotcha.
So that's nice, right? Musk stated that SpaceX hopes to launch 2 cargo missions to Mars by 2022, and then 4 missions, 2 cargo and 2 manned missions by 2024. Quote, then build up the base, starting obviously with 1 ship, then multiple ships, then start building out the city, then making the city bigger, end quote. And
it's basically SimCity for the moon and Mars.
There's some concept imagery here as well. This was pretty cool when the city started getting bigger and bigger. So it's looks like a computer chip. Yeah, it does kind of look like a computer chip. That's a good call on that, Kyle. I like that. But yeah, it's all very inspirational, very interesting to see somebody get up on stage and
talk about things
and
like
say
this.
Yeah. And then finally,
and not really sound like a crazy person,
right,
actually.
Right. Finally, Musk showed a video revealing that SpaceX endeavors to apply this same ship that can transport people and cargo to Mars to the application of transporting people around the Earth in incredibly short travel times. And we have a video to show you guys on that. This was kind of like
we're going straight up Wile E. Coyote.
Yeah.
We're shooting rockets. We're doing it.
This was like the and one more thing at the press conference, because then
once we have this whole infrastructure set up, and why not just use it on Earth?
Yeah. So let's jump over here. Kyle, you let me know when you're ready to press play there, Bob.
Future.
Here it is.
I forgot my luggage.
Yeah, none of these people have any luggage.
They're just going across the whole Earth with no luggage. It's okay. We get it. It's a concept.
Yeah.
So you would actually be leaving the Earth's atmosphere when you would be traveling to another part of the Earth with this.
Yeah.
So once you're up here, there's no friction or anything. You can go real fast.
I love that the booster just turns around and just comes back.
And it's like, yeah, we need that. It's cool.
You'd be going 27,000 kilometers an hour.
Way faster than anything we can do right now, right?
Way faster. Way faster.
And what's so crazy about all this, it looks so bizarre, but it's actually reusable. Like, that they actually managed to land rockets and reuse them is so crazy.
Yeah. I mean, we've seen it.
It's worked. It's done. Yeah.
Like,
they're not just saying they could do things that they haven't proved. They've done it.
That is the hardest part, and that's crazy. There you have it, folks. Future is upon us.
Pretty sweet.
Tom, what do you think the likelihood of this becoming a reality is?
Yeah, it's tough to say with this kind of stuff, right? Because I want it to be true so bad, where I think half the time I kind of put my stock into it sometimes. But the game plan of the whole thing seems to make sense, where they've started with the rockets, they've learned to be able to reuse them, land them, they've been building up their technology, now they're setting up an infrastructure of reusable rockets that have even more utility.
Yeah.
Exactly. Being able to send more satellites up, being able to clean up space debris, do all these things to then build in more revenue. So that's what I think was the key part of his whole thing. Not even the technology, not all the other stuff. I think his main point he was trying to bring up is that this is actually a lucrative thing to do.
Yeah.
Once you get reusability in space, we're going to make money off of this, and then that's how we're expanding on it.
Mm-hmm.
That this reusability is so profitable in the space industry that I think that was his main point, that people don't even realize that the sky is literally the limit with making money on this thing, because now that once you have the system in place, it's like a working business. Like you got all your FedEx trucks, now they're going to drive your products.
Yeah. I think
it is a really, it seems like a clear picture, and definitely possible within maybe 5 to 10 years later down the road, but definitely possible.
Yeah, I think that if anybody's going to make a reality out of this, it's going to be Elon Musk, because, you know, my original thought with this, before I watched the 45-minute long presentation,
mm-hmm.
I just caught the clip of what we just watched together, right? This concept video of...
Yeah, I saw that video first before I watched the whole thing.
And I originally thought to myself...
I was like, this is a little much, right?
Yeah, because, you know, I jumped to the fact that, well, we have developed the infrastructure for maglev trains, and where are those,
They're
right?
Nowhere,
They're nowhere in the United States. But then the difference here, Tom, is that this is already a private company. It is a CEO that has the means and the vision to do it on his own dime, in a sense, right? Like Elon Musk, yeah, he's not going to bankrupt SpaceX based on some
crazy vision, yeah.
Right, some uncalculated crazy vision, but to be able to get on stage and say, like, this is how we're going to do it. I figured out the roadmap, and it'll be profitable along the way. I think it's like...
it's not like we're really trying to make this crazy vision happen. He's saying it's almost an inevitability once we have these large, reusable, heavy payload rockets. It's sort of a moneymaker in itself, so that this is the way to go.
Yeah, and it doesn't depend on taxpayer money. It's, you know, like...
Yeah,
that's the crazy...
They're already launching satellites for money.
Right.
They're the only reusable rockets right now, right?
Yeah.
So that's where you go.
Yeah.
They're going to be making the money. Cool stuff.
Very cool stuff. So we'll see. We'll obviously be looking forward to it.
James says it'd be sweet to have breakfast in New York, get lunch in Tokyo, and then dinner in Barcelona.
Yeah.
What a world traveler.
Yeah. And then go to the moon for the weekend.
Yeah. Go to the moon.
That'd be awesome.
catch some plagioclase feldspar.
Yeah.
All right.
Next story, number 2, Tom. For the 4th time, gravitational waves resultant of a black hole merger has been detected, this time by the joint LIGO and VIRGO 3 detector collaboration.
So we have talked about LIGO multiple times, and then we mentioned VIRGO, but this is the first time that LIGO and VIRGO have been used together when observing black holes, right?
Correct.
Black hole collisions.
Yep. So, yeah,
And just to remind everybody, we're detecting ripples in space-time from black holes coming together, sending ripples throughout the fabric of space-time.
Yeah, and it's a big deal. Don't get me wrong.
Mm-hmm.
I love that how big of a deal it was. I was pleasantly surprised, you can say, that this overwhelmingly stole like the focus of my social media pages and all the news outlets that I follow. But I was kind of like, okay, we've done this. We've done this a few times now. And I actually, I'd like to see more of, the further implications of what this all means, rather than just the confirmation of the finding
what are we
itself.
looking for and why are we looking for them?
Yeah.
As opposed to just we found more gravitational waves.
Yeah.
Yeah.
It's going to be a hefty discovery when we know, when we can apply we know that the universe works like this because of all this gravitational wave study that we've done.
Yeah, eventually down the road,
It'll
is
come.
going to be a part of it.
It'll come. So I want to show a video courtesy of Max-Planck-Institut for gravitational physics. As we do when we cover these gravitational waves stories, this is the simulation of what it looks like, so the spinning, and you kind of see the waves ripple out afterwards.
Mm-hmm.
So Kyle, if you don't mind bringing that up for me. There's no sound, so we don't have to put the headphones on. It's just a nice little quick video here. Yeah, a nice little animation simulation.
And we've showed something like this a few times.
Yeah. So you got your 2 black holes here. They're orbiting around a common center of mass, and they are gravitationally attracted to one another, so they are going to eventually merge into one another. And when they do, Einstein's theory of general relativity says that a lot of that mass can be converted directly into energy that dissipates in the form of gravitational waves.
Yeah, so it's pretty much almost the same concept of throwing a rock in the water and then that energy being dissipated away as waves in the water. Sort of the same concept. Sort of,
yeah. And then we feel that ripple by measuring very precise lasers that are set up onto interferometers. And we've done this 3 times before with LIGO, and now we've added the VIRGO detector.
So now we have 3 detectors.
Yep, in Italy, which helps, and we'll go into how that helps. So a news release courtesy of LIGO's official webpage states the following. Quote, the LIGO scientific collaboration and the VIRGO collaboration report the first joint detection of gravitational waves with both the LIGO and VIRGO detectors. This is the 4th announced detection of a binary black hole system and the first significant gravitational wave signal recorded by the VIRGO detector, and highlights the scientific potential of a 3-detector network of gravitational wave detectors.
So do you think we're moving towards more than a 3-detector eventually down the road?
I think inevitably, yeah, that most...
as we can get more of them set up.
Yeah, most countries and most scientific communities are going to want...
a detector.
Yeah, they're going to want a hand in this too, in some sense. The 3-detector observation was made on August 14th, 2017 at 10:30 Universal Time. The 2 laser interferometer gravitational wave observatory LIGO detectors, located in Livingston, Louisiana and Hanford, Washington, and funded by the National Science Foundation, and the VIRGO detector located near Pisa, Italy, detected a transient gravitational wave signal produced by the coalescence of 2 stellar mass black holes.
So I don't know if you'll be able to answer this question, but last time we were talking about neutron star mergers, right? And seeing if we could detect gravitational waves from that. Do you remember how we can tell the difference if it's between neutron stars as opposed to black hole mergers?
I think it is just the
The
tracing it back,
magnitude or the source, like where it came from?
I think it more has to do with getting an estimate on what the masses were prior to collision. So neutron stars are less massive than stellar
black
holes. So I think that's the main difference between it. The other thing was that the neutron star collision, there was a source of light. If I'm not mistaken, right? There was a electromagnetic release as well that was detected, and you can't have that with black holes because black holes don't emit light.
Yeah.
So which is why they're black holes.
Okay.
And there was no detection of electromagnetic radiation with this one.
Okay. I just wanted to make a distinction between the two.
No, that's good. That's a good point. Skipping down a little bit here. The detected gravitational waves, ripples in space and time, were emitted during the final moments of the merger of two black holes with masses about 31 and 25 times the mass of the Sun and located about 1.8 billion light years away. The newly produced spinning black hole has about 53 times the mass of our Sun, which means that about 3 solar masses were converted into gravitational wave energy during the coalescence.
So that's sort of where this all came from, right? When Einstein was doing all the math, he was saying when this happens, we're losing mass, and that mass needs to go somewhere. Mass is equivalent to energy, he showed, so that mass gets shot out through the universe, basically, as a form of energy.
Yeah, this is really just a...
conservation of energy?
Yeah, conservation of energy and the E equals mc squared equation being proven again here.
In another setting.
Yep.
Pretty cool stuff.
So I have an image to show you guys. This is courtesy of LIGO and VIRGO. This is a comparison chart of the 4 black hole mergers that we now have confirmed.
Yeah, so we're trying to categorize and learn what typical black hole mergers look like.
Yep. And so the most recent one is this one all the way on the right-hand side here. So you can see it's basically produced the second largest black hole resultant of the merger. Not as large as, I believe, the first one that was detected back in 2014. But yeah, not too much different in terms of size and mass as this, GW 170104, which was previously discovered. So, yeah, there you have it. Another quote here. Overall, the volume of universe that is likely to contain the source shrinks by more than a factor of 20 when moving from a 2-detector network to a 3-detector network. The sky region for GW 170814 has a size of only 60 square degrees, more than 10 times smaller than with data from the 2 LIGO interferometers alone. In addition, the accuracy with which the source distance is measured benefits from the addition of VIRGO, end quote. And so, basically, the more detectors you add, the
finer resolution, right?
Right, the better approximation you have of where the source came from. And so I have one more image to show you guys. Again, courtesy goes to LIGO and VIRGO for this. This is a sky map showing you the range over where these black hole mergers have been traced down to. And so kind of these long smears here in purple and orange and blue. And the green one here, these are from the other detections prior to VIRGO joining the collaboration. And then the newest one down here in kind of this yellowish green color, that is this most recent 4th detection. And you can see obviously it's a much smaller piece of the sky, and so we have a much better handle on where this happened in the universe, that's ultimately cool, I think the goal. So pretty awesome.
Einstein, man.
Einstein. Last quote here with the LIGO news. This is from David Schumacher of MIT. He says that this is just the beginning of observations with the network enabled by VIRGO and LIGO working together. With the next observing run planned for fall 2018, we can expect such detections weekly or even more often. End quote.
So that's going to be next fall, right?
Yes.
Okay. So we'll follow up.
Yeah. I don't know that we'll follow up weekly.
No, probably not every week.
Yeah, then it's going to become old news pretty quickly. But that's fantastic, right? That's what I'm more looking forward to, is when this does become a more frequent occurrence, and then studies can be done to extrapolate on what does this mean? What does this
what
all
can we
mean?
learn from that? Yeah.
Yeah, that I'm really excited for. How we doing in the chat?
Doing well.
Doing well. All right. Cool. Moving right along. Number 3. Some sad news, Tom. NASA's James Webb Space Telescope launch has been delayed.
So we've mentioned the James Webb Telescope a few times when we're talking about like future missions and looking forward to what James Webb will tell us. Because we've talked about a few stories that they sort of want the James Webb Telescope's information before being able to say really what's what, right?
Yeah. So, James Webb Telescope is going to be basically the successor to the Hubble Space Telescope. It's going to be bigger.
It's got some big shoes to fill.
Yeah, oh, yeah. It's going to be able to do quite a bit more than what?
That's exciting, because Hubble did a lot for us.
Absolutely. According to NASA.gov, quote, NASA's James Webb Space Telescope now is planning to launch between March and June 2019 from French Guiana, following a schedule assessment of the remaining integration and test activities. Previously, Webb was targeted to launch in October 2018, so not too much further, kind of a half-year delay here, not too bad. The change in launch timing is not indicative of hardware or technical performance concerns, says Thomas Zerbuchin, Associate Administrator for NASA's Science Mission Directorate at headquarters in Washington. Rather, the integration of the various spacecraft elements is taking longer than expected. I believe him when he says that, although I doubt he would tell us if it was actually if it was the other bit of it. Existing program budget accommodates the change in launch date, and the change will not affect planned science observations, so that's good. And what else do we have here? Webb spacecraft and Sunshield are larger and more complex than most spacecraft. The combination of some integration activities taking longer than initially planned, such as the installation of more than 100 Sunshield membrane release devices, factoring in lessons learned from earlier testing, like longer time spans for vibration testing, has meant the integration and testing process is just taking longer, said Eric Smith, Program Director for the James Webb Space Telescope at NASA headquarters in Washington. Considering the investment NASA has made and the good performance to date, we want to proceed very systematically through these tests to be ready for a spring 2019 launch. Makes sense?
Yeah, seems like there's really nothing to be super worried about.
Nope. The James Webb Space Telescope is NASA's next great multi-purpose observatory and will be the world's most powerful space telescope ever built, serving thousands of astronomers worldwide. The 21-foot, 6.5-meter diameter infrared optimized telescope is designed to study an extremely wide range of astrophysical phenomena, the first stars and galaxies that formed, the atmospheres of nearby planets outside our solar system known as exoplanets, and objects within our own solar system. Webb is an international project led by NASA with partners in the ESA and the Canadian Space Agency. End quote. Tom, what do you think about the delay?
I guess it's to be expected, right?
Yeah.
It's a pretty complex telescope that they're really trying to make sure it gets done right.
Yeah, there's always delays with these kinds of things.
Yeah. It's a lot of complicated technology, a lot of testing, a lot of a lot of checks and make sure this works, that works.
Yeah, I like that they give us a time frame, like
initially,
because it kind of gives us nice little things to look forward to. But yeah, I never take them at face value. Like, in the words, Karen Riley in the chat says, "Better safe than sorry." I agree. In the words of the great Shigeru Miyamoto, Tom.
Okay.
Do you know who Shigeru Miyamoto is?
No.
He's the guy that invented Super Mario Brothers.
Oh, okay.
He says a delay is a good thing because, and he's talking about video games, but it kind of applies to everything. If you put out a bad game and it's a bad game forever, right? But if you delay it and then it gets better, then you can put out a good game. So delays are a good thing. Ultimately.
Makes sense.
Yeah, it makes sense. Makes sense.
Then we got two quick little
things here. Number 4, Tom. Bill Nye, Science Guy.
Who's that?
A documentary starring the television personality and CEO of the Planetary Society is making the rounds to select theaters starting on October 3rd.
So it's a self-documentary of the man, the myth,
the legend,
Bill Nye.
These screenings will take place prior to PBS's airing of the documentary as part of its POV television series. PBS acquired the North American distribution rights back in June, while the film originally debuted back in March at the South by Southwest Festival. And there's a trailer for us to watch if we want to
Sure.
take a gander at it.
I never would have thought that Bill Nye would still be relevant when we were watching him in middle school biology.
Me neither, man.
But
Me
you're
neither. Kyle, let me know when to press play on that bad boy.
His favorite scientist, Bill Nye, the Science Guy.
Just the start of things. We're getting things wrapped up.
It was really the 1990s. I wanted to make young people excited about science again. Science! I studied at Cornell University. I decided to take astronomy from this famous professor, Carl Sagan. He said kids resonate to science, and I really embraced that.
A lot of people of my generation attribute their interest and love of science to Bill Nye.
You would just see the TV cart come in and then just hear, Bill, Bill, Bill.
The Science Guy show contained the science that excited Bill. And you, the viewer, can't help but be just as excited as the instructor.
I was asked to talk about selfie fatigue. Here we go. Go! I'm pretty sure it shortens your life. Science Guy show is over. I got to move on to something bigger. Nowadays, I'm talking to adults, and I'm not mincing words. Climate is changing. It's our fault. We got to get to work on this. This is where we see the smoking gun.
This is raising sea level. This is drowning Miami eventually.
Bill successfully transitioned from Bill Nye, the science guy for kids, to the science statesman.
We're going to space! Rocket science.
That's the bottle I'm drinking with Bill.
Mission control.
Go ahead, Bill Nye.
I would just like to say the following thing.
We are, dare I say it, changing the world.
Joe Bastardi challenged me to a debate. You agree with that?
Bill, you don't want to go here.
Currently, Joe Bastardi is a climate denier. If Joe changed his mind, that could be very influential.
I'm not trying to save the world.
Bill Nye himself is not a scientist.
I don't have a PhD. I talk to the experts and hold the evidence in my hands. These people who are denying science, and especially denying climate change. We just can't have this. If we raise a generation of kids that can't think critically, we are headed for trouble. My dad's big thing was leave the world better than you found it. My drive to do all this is from my parents. I try to be worthy of them.
Pretty cool. How do you feel about it?
I like Bill Nye. I think that he's great. I think that he's a wonderful communicator. I think that he does a lot for, children's understanding of science, and now to a certain extent, adults' understanding of science, curriculum and concepts.
Yeah, I think that's true. I think overall, though, for me, the biggest impact that he's had is just making science relevant in the news. Just getting people to talk about him at least.
I think there's a danger here, though,
Yeah,
Tom.
I do agree with that, yeah.
Is that Bill Nye has been lumped into this political echo chamber as being somebody who fights for the climate change agenda without really having the full background of, being somebody who studies that explicitly. And I think that can be really damaging, especially in today's political climate. No pun intended there.
Yeah, a lot of people try and discredit the whole climate change argument by using the fact that he's one of the large proponents of it and trying to discredit the whole climate change theory based on saying, well, the figurehead, the spokesperson for it, isn't even a real scientist, and that sort of thing.
I just fear...
Excuse me.
You're excused. I just fear that this film is gonna do more harm than good.
Yeah, I don't see this really doing any good.
Yeah, it's I'm sure it's a nice film, but it's not
a nice story of his life.
Yep.
But it's not gonna do anything to forward the science community, right?
Yeah, I think right now we are pretty divided on a number of topics, and everybody's dug in.
Yeah, you can just look at. Remember, we showed the preview for An Inconvenient Truth, the sequel.
Mm-hmm.
That movie came out. Nobody talked about it. It was a bad movie and did nothing to clarify, to educate, to help the scientific community convey the ideas of global warming. It really was more Al Gore, more people saying, I don't want to listen to this or believe it.
Yeah.
And this is another movie that's, I don't think is going to do anything to sway people's minds or ideas or anything.
Yeah. So, you know, I applaud Bill Nye for doing what he does as far as being a communicator. But I fear for him in a sense that he's going to just, like I said, get lumped in and get totally cast aside into this overly political world that we live in right now, and that saddens me to a degree, because he's just Bill Nye, you know, he's a good guy.
Yeah, he was sort of thrust into the media and the political limelight where everybody was like, we need a good spokesperson, right? And they kind of reached out for him, and it didn't really go like beautifully. Like, people were attacking his credibility and who he is and what he is. But I think if you take him for what he really is, somebody getting people excited about science from the beginning, I guess it's kind of cool to follow his story. But
yeah. We'll see.
Yeah,
we'll see how it goes. And finally, Tom, BBC released the first official trailer for its upcoming documentary series, Blue Planet 2. The trailer, titled The Prequel, sees narrator David Attenborough reprise his familiar role in the series,
He's the same announcer for Planet Earth, right?
Yeah, yep. He does pretty much most of the BBC stuff, nature documentaries, as well as a musical collaboration between composer Hans Zimmer,
the GOAT,
and acclaimed band Radiohead.
Radiohead and Hans Zimmer, the duo.
It's a little strange.
Is it? Okay.
Yeah, a little bit. It's all right though. So let's watch the video. Credit goes to BBC America for this one. And Kyle, you let me know when to press play.
The ocean, the largest habitat on Earth.
Man, HD cameras, man. Unreal.
A generation ago,
yeah, thank goodness.
Series, The Blue Planet took us beneath the waves. But now we know so much more.
I cannot wait for this.
Take
just putting that out there.
We might have to invite Mr. Ocean Ryan Nash over for this one.
Oh, we sure will.
Baby sea turtle migration.
Get that drone footage. Kyle, you can get that drone footage, right?
New science and new technology
Starfish are so weird.
allow us to voyage further and deeper than ever before. From the restless shores of our coastline, where dolphins spit to trick their prey, to enchanted undersea forests, where fairy tale creatures dwell. Across vibrant coral cities, bustling with ingenious inhabitants.
The footage is unreal.
Right?
To the vastness of the big blue, home to fearless ocean wanderers. And down into uncharted depths, where some of Earth's best kept secrets hide. Newly discovered dancing yeti crabs. And landscapes never seen before. Coming soon.
It's great to see the sequel coming out.
Yeah.
Stuff just keep going.
This is Blue Planet 2.
So now, do you know if Blue Planet 2 is a series, or is it like a one-time?
It's a series. It'll be multiple
Episodes?
Yep.
Gotcha.
No release date.
No
Release
release date, though.
window, which I can appreciate. I think they were originally targeting the end of 2017, but now it's been pushed into early next year.
Gotcha.
So, which, again, delays are good. But man, I can't wait for this. It's gonna be awesome.
Wow.
Pretty exciting, Tom. Pretty exciting.
For real.
I
feel like within our lifetime, we went from reading like little books about animals to getting the most wild HD footage you could imagine within our lifetime.
Yeah.
Wild, man.
It astounds me, especially with the Blue Planet series and the even the Deep Ocean series or episode of Planet Earth, the original Planet Earth, like how alien
all those things are.
Yeah, everything in that habitat is to us, and it's here on our own planet, and it's just so. It is a world of its own down there.
Yes, it is.
It's really, really interesting, really inspiring.
Yeah, when you sort of just real quick think about like the history of everything, right? So you have dinosaurs 65 million years ago. There's still all kinds of stuff in the ocean at that time.
Mm-hmm.
Asteroid comes, the dominant species extinct. All the little mammals, the rodents hiding underground from the dinosaurs are our descendants. Here we are, and then the ocean was sort of, the deep ocean has just really been there throughout.
Yeah.
You know?
It's crazy stuff.
Crazy stuff down there.
Yeah. What did you think of the trailer? It's long, obviously, but what
really cool, yeah.
Yeah.
I think a trailer like this gets people excited.
I think so too. My girlfriend Kayla pointed out this little interesting tidbit to me, that the music particularly evokes this kind of emotional, like, I don't want to say sadness, but like a more somberness and like
instead of awe and like
right. If you think back to the Planet Earth 2 trailer, it was very like bum 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 bum, like very in your face, like jack you up kind of footage, and this is a much more kind of seductive trailer. So I don't know why, but it's
a different tone.
It's a different tone. It's a different vibe for sure. But I'm looking very much forward to it. Can't wait. Tom, what's going on in Tom's Corner this week?
So we're gonna just talk real quick. We only have a few minutes left on the show. I didn't really want to get too deep into the topic of it, but obviously everybody almost is aware of the news of the shooting in Las Vegas, and I just wanted to mention a little bit of things that I've read a whole bunch of different things. Didn't really learn too much, gain too many insightful things, but I figured if we just bring a few of our maybe quick dialogue, it might shed some light on a few things. So I wanted to start with, we talked before that we're never really going to take away people's guns, right? I don't think that's ever a feasible thing to just say we're going to try and limit people's guns as much as possible. And we sort of brought up the point that it's more of a psychological feeling of security and safety and sort of control of your own life by feeling like you sort of have a hand in your own destiny, right? And I can see the drive and the need to have that sense of feeling insecurity, and I don't think we're ever going to see a United States that largely gets rid of people's guns, right? I don't think that's really going to happen. So by taking that into account, I wanted to bring up the point that it's not, every time this comes up, we always talk about guns. By we, I mean like social media and
just the general narrative, right? It's always jumps immediately to gun control.
And obviously there's a political part in this where many people are saying we need way, way, way less guns, way more regulations, way harder to get permits, this and that. And then there's the other side saying that, well, if all those people had guns, who knows if that person would ever even have the guts to go in there. And there's that sort of side of the argument. And the thing that I wanted to bring up was that it's not really a gun issue, right? When we're talking about things like this, we're more talking about a mental health issue, right? Because this isn't a person defending their home with a firearm that they kept, that they were defending themselves. This is a mentally ill person, a sociopathic person who's out on, a terrible rampage for what's really not a logical, coherent reason. It's more of a mental illness, right? As that's the way I like to look at it. And I think when people are trying to look for a solution, like, what do we do? How do we move forward? What do we do? Do we ban guns? Like, what do we do? People want action. And the only thing that I think that I would like to put out there on behalf of us is that I think there's a horrible lack of development of mental health just in general in the United States. When we were sort of going back and forth before talking about, just addiction to substances and all kinds of different things, that the mental health within our country is probably not very good overall.
Yeah, certainly not the strongest.
Yeah, and just start implementing things to sort of counteract that and educate from an earlier standpoint. I think that sort of idea you can get on the bandwagon for that, right? Teaching kids about, meditation and thinking about respect for life and just all kinds of things that we can start educating young people about. I think that's where it really starts. Because once you get older and you start having ailments, right? Because this was an older gentleman in his 60s, I believe. And I think at that point, once you start having some sort of mental deterioration and things, that it could spiral quickly out of hand. There's obviously, like we mentioned, there's guns sprinkled throughout the country to sort of exacerbate the mental illness issue when they lash out like this. But I think that's really where you need to look at it from.
Right.
Not a gun issue, but from more of a psychological standpoint of what is the mental health of the people that are engaging in these acts.
Yeah, absolutely. I think that's the most important thing to not lose sight of, right? Is that, yeah, I mean, the guns are the tool that are used in these horrible shootings and mass murders, and there is a conversation to be had about the regulation of those tools, right, of firearms in general, but let's not lose sight of the people behind the action. And I think you're absolutely right that there's a lack of understanding of mental health, and that 9 times out of 10 when we hear about these things on the news, the person responsible suffers from some sort of mental health illness, and
nobody saw it going this way, but they knew they had an issue.
Right.
I mean,
yeah, and we lose sight of that, right? We very much like to argue over what the right course of action is regarding the guns themselves, and we lose sight of I think the real issue at hand is that, yeah, people need to have a better sense of control, right? And owning a firearm probably gives them more of a sense of control in the moment, but you need to have a sense of control over your mind and your actions before that, way before that. And that's something that easily gets lost along, from childhood to the time when you can own a firearm. So yeah, I think that's something that we should take stock in and
yeah,
hopefully help develop further and further in forms of education down the line.
And just this point isn't really related to this at all, but I was recently following up on the Linkin Park singer, their lead singer Chester, who committed suicide. They recently posted a video of him and his family. They're laughing, having a good time, and he's a millionaire, made all kinds of money. He's pretty much set for life, and at face value, even to his family, he seems like a happy person. But I think so many people underestimate and overlook what really goes into making a person, right? And how you can have pain existing with happiness at the same time.
Mm-hmm.
And I think a lot of people overlook that if you're smiling and doing certain things, that you're not hurting, not in pain, not needing assistance. And that's sort of the general outlook I think that our country has at this point in time. But I think the same thing we were talking about with education, it just needs to be at the forefront of what we're trying to teach students in school. And I think we need to put that into the curriculum, that we're trying to teach not only mastery of material, of things like math, numbers, and reading and all that, but core to their education should be things like values and just techniques of like breathing and meditation, and just understanding really what it means to be a person before we thrust all these ideas and knowledge into them before ever dealing with the person at all.
Yeah, and then dealing with life's stressors without having that peace of mind, that becomes too much to handle for some people, obviously.
Yeah.
So yeah, it's definitely something we need to address.
But yeah, people are always looking, what can we do? And people are always saying, call your congressperson, let's try and get stricter gun laws and this and that.
Yeah.
And the guns are never going to solve the issue.
No.
There's so many out there, and we talked for a long time, and we're going to wrap this one up, but I mean, I think that's the way you can start going for action at this point in time.
Yeah, it makes the most sense. It's the most plausible, pragmatic solution right now, because people aren't going to hand their guns back. It's just not going to happen. So, yeah, it is what it is.
Yeah,
Tom?
Terrible to see, and
yeah,
I guess, just try and learn from it, I guess.
Yeah. Tom, thank you very much for raising that point, and that was a sound Tom's Corner, and I applaud your getting to the root of the problem there, because I think a lot of people like, again, to dig into this political field that we have going on.
And just pick a side. And,
yep.
Yeah.
But yeah, so thank you for that. And thank you for joining me on this week's episode of trèSci Weekly, Tom. We had a good episode here, Tom.
Yes, we did. And we'll follow up next week with the Nobel Prize winners, and we'll see what else this week brings us.
Yeah. So stay tuned. If you, of course, see anything that you would like us to elaborate on in the coming week, make sure to tag us on social media so that
either Facebook, Twitter, email,
or YouTube,
whatever. Comments, let us know.
Let us know, and of course, we'll get back to you on those things next week. Thank you for joining us, and we'll see you